Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome, everybody, to today's episode of Pepperl+Fuchs Plug-In, and I have again with me Theo Woodson. Hi, Theo.
Hey, Helga. Nice to be here.
Great. Thank you for coming. Theo, last time we talked extensively about the construction of a cable, and some listeners may remember that I think we set the record for time. It was probably a 15-minute plus episode, but very, very detailed, very good. Today, we're going to talk about a component we glanced at but didn't talk much about, and that is, of course, the
cable and jacket materials.
Yes, cable and jacket materials. There are a lot of those, and they're there for a good reason. Not only because one color looks better than the other.
Yeah, that's right. I like the green ones.
There's a good reason for having them. So tell us a little bit about the jacket materials that are out there that are frequently used, and then we dive a little bit deeper.
Sure. So it's all about choosing the right cable. Reliable connections depend on choosing this right cable jacket material. And so you might be curious how automation applications and cable materials are related. Well, you can choose the right cable for an application by several factors, but material selection is one of the most important. The material determines the properties and how that cable can withstand a given environment.
And that means temperature, mechanical aspects,
right? Chemical
rubbing, it is chemical things,
right?
All of those, right?
Right, that's right. So we do offer several different materials that provide different levels of protection in those different environments.
All right, let's dive into those.
Right. So the first one is called PVC, which is polyvinyl chloride. And that's for the most straightforward applications. It's a solid and economical choice. It's mostly used in areas subject to moderate mechanical strain, like packaging machines, assembly, and production lines. It's very affordable, and it has a good effective resistance to chemicals, suitable for the food industry, and it's also resistant to many alcohols and inorganic corrosives like acids and salts.
So it's a for its price, it's a good material.
Yeah, it's a very good economical choice. Probably it's definitely on the lower end of the cost for among all the different cable materials.
Okay.
It's easily strippable, it's suitable for some flexible installations, and it's very durable.
Okay, good.
So,
what's the next one you want to talk about?
The next one we have is a very common one. It's called PUR, and that stands for polyurethane. Polyurethane cables are for somewhat more complex applications. It's also durable and highly flexible.
Much harder to strip, though. I can tell you from experience. It's not as easily stripped as a PVC cable, but that goes along with being mechanically more resilient.
That's right. So the PUR is used for more challenging and some of the most challenging environments.
And there are, sorry for interrupting, there are a couple of different variants that we should be talking about.
That's right. So we have several different variants. The PUR-U, which has a UL approval, very highly flexible. A PUR-A, which is for automotive, very resistant to welding sparks for the automotive industry. PUR-O for the outdoor, very durable for outdoor applications.
And what specifically makes an outdoor cable?
Right. Well, it has very good resistance to the environment you'd find outside. UV protection, seawater protection.
Essentially sun. UV means sun.
The sun, that's right. Yeah, ultraviolet rays. Seawater, oil resistance, diesel fuel resistance, and it has the PUR-O, outdoor rated cable, has the biggest temperature range from negative 50 degrees Celsius to 105 degrees Celsius.
Okay, that's quite wide. And I think there's one more type we should mention.
That's right. The PUR-R is for robotics, for extreme mechanical stress, and very highly flexible for demanding robotics applications.
Okay, good. So PUR is a tough material. It's a very good material, and it has different kinds for different sub-applications.
That's right. So many great properties that you can investigate further on.
And I think now we come to probably one of my favorites.
Oh, yeah? Then you must be talking about the POC.
Absolutely. I think that stuff's amazing.
Yeah, it's a really cool composite. And that's what POC stands for, is polyolefin composite. And that's our weld bead resistant variant of cable material. And this is for the most challenging scenarios. And it was specifically designed for the welding industry.
Yeah, we've done YouTube videos where we take a solder iron, put it on one cable and another one, and they all kind of melt and burn away.
But torch to it.
But POC is really a fantastic material.
Right. It really comes into its own for applications in any kind of welding sector that can't be solved with other irradiated PUR cables.
Oh, irradiated. You threw out a new term.
Right. So irradiation is effectively the practice of applying an ionizing radiation to a polymer to cross-link it. And cross-linking is joining polymer chains with ionic or covalent bonds. And what this does is give them better mechanical, thermal, or mechanical properties. And at PNF, we're phasing out some of the irradiated materials that we used.
Why is that?
There's environmental and health risks, and it's also more expensive to do. When we can replace those materials with more application-specific ones like POC.
I see. Okay, good.
That's right. So we have another one called STOW, or STOOW. That stands for Service Thermoplastic, Oil Resistant, and Weather Resistant.
Okay.
And so this type of cable is a PVC-based material. The STOW designation is just an approval.
All right. It's essentially the outcome of a test. Does it survive this type of demanding, abuse, let's call it?
That's right. So, but it's effectively made of PVC mixture. This is predominantly used in the American market and really common in automotive applications, but other heavy machinery and similar related environment applications. So it's tried and tested for outdoor use, and it has excellent flame retardants because it's made of PVC, and then also approved to up to 600 volts.
Oh, okay. So AC applications are definitely a possibility.
Yeah, that's right. The high voltage rating is sometimes an industry standard, could be a customer wants to spec all their cables, or also that larger cables often just come rated at that higher voltage.
Mm-hmm. Good.
And so lastly, one of the materials we have is PP, or polypropylene. That's typically used for the food industry. It has a great mechanical load capacity. They're halogen free. They're tested for food safety and public health. For drag change, they're torsion resistant, and also have a wide temperature range.
Okay. Sounds like a great cable.
Yeah, so many great cable materials that are, again, very application specific.
All right. I think that's it. So you think about your 5 words, as you know, and I'm going to try to give it a quick summary here. So essentially what Theo was talking to us about is jacket materials that make an application work right. Don't want to go through them all, but they go from basic, where expense is maybe the most important part and they're not very demanding, to something where a POC cable would be used that's amazing under unbelievably hot temperatures and in weld environments. So there's a lot of different materials out there that all have their specific needs, or all they have their specific applications. So, Theo, having said that, what are your 5 words today?
Right. So my 5-word phrase for this is don't forget your cable jacket.
All right. Don't forget your cable jacket.
Right. And what that means is to effectively always remember that when you consider a cable for an application, a great place to start is with the jacket material. You weigh the properties of that material against the environment of the application, and you'll be able to make a better decision, and all will benefit from that precise selection.
Yep. Very good. Well, Theo, as always, I appreciate it. Thank you very much for giving us this insight into jacket materials. Take care. Bye-bye.
Thanks. Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.